Hi guys, welcome back to part 2 of this video. In part 1 of the video, we extracted the temperature and the pressure data from the Dortmund databank using Python, specifically pandas, and then we plotted it using Plotly to make a graph of our temperature versus our vapor pressures. And in today's video, I'm going to show you guys how we can do a nice linear regression of that data using the parameters for the Antoines equation. And the parameters are A, B, and C. And this can be really useful from a chemical engineering standpoint because with Antoines equation, we only need about 3 or 4 data points to make a really nice linear regression that is very accurate. So what this means is we can save a lot of time and money by only doing a few number of experiments and then using Antoines equation to plot it out for us. Okay, so let's get started. First thing we're going to want to do is we're going to want to import another library that we'll need to solve this problem. So we're going to do from scipy.optimize import minimize. And then from here, I've already separated this section off just to indicate we're working on part 2. And now we're going to want to include our Antoines equation. So if you guys remember, our Antoines equation is going to be taking log base 10 of p is equal to a minus b over c plus t. So our parameters here are going to be a, b, c, and t. So let's create a function. So define model a, comma, b, comma, c, and t. And those are going to be our parameters for our Antoines equation. Now we're going to have our model return a minus b over c plus t. Perfect. Next, we're going to create another function called sqerror. So define sqerror, and the values we're going to want to take for sqerror are going to be x, comma, t, comma, and log of p. Oops. And for this one, we're going to need to make a model of our pressure. And then, so this one's a little bit complicated, so hang in there. We're going to make a model of our pressure, and then we're going to subtract that model from our log base 10 of our pressure, which is our original data. And then we're going to sum square error that so that we can have a nice graph and a nice linear regression. So let's create a variable model p is equal to model of x0, x1, x2, and then t. And now we're going to have our error equation. So error is equal to np.sum. This is the sum squared error part I was talking about from earlier. So we're going to do is equal to model p minus log of p squared. So now we're going to be doing a sum squared error of this and return error. Perfect. Okay. Now from here, we're going to want to take this variable, our sum squared error, and then we're going to minimize it so that we can fit this equation on this line. And the way we're going to do that is we're going to create a variable called result, and that's going to be equal to minimize our squared error, and for our x0, as you can see right here, it's asking us for some x0 functions, or for some x0 values. So what that's telling us is we're going to need to make a guess, an initial guess, to potentially minimize our equation. So let's make some initial guess values. So a guess is equal to let's say 10. B guess equal to, I don't know, let's try 1,000, no, let's try 2,000. C guess is equal to, let's say 10 again. And then let's create a variable called x naught, and that's just going to be equal to the array A guess, B guess, and C guess. So going back to here, we have our SQ error. X naught is equal to x naught. Next, let's do args. And args is equal to. So we're minimizing our SQ error by changing these x values. So our A, B, and C. And our arguments are going to need to be t and log base 10 of p, because we haven't included that yet in our SQ error. So t, comma, log, underscore p. And lastly, we're going to do tolerance. Tol is equal to, let's do a small number, just to let Python know that we want a very small error, which means we'll have an accurate result. And lastly, let's print our result to see what values we're getting. As you can see, when we print our result, our x values come out in the form of an array, and essentially it gives us 3 values, and what this is telling us is our A guess actually ended up being 10.2. Our B value for the Antoines equation ended up being this number, and our C value ended up being negative 36. So now we have our A, B, and C values. So the last thing we're going to want to do is plot these values so that we can have them on our plot from earlier. So let's create another variable called tModel and set that equal to np.linspace of t0, oops, and then if you remember from the previous video, we have 26 temperatures, so to 25, and let's have 100 spaces. And finally, we're going to do fig.add scatter. We're going to set our x values equal to tModel. Our y values are going to be equal to our model that we defined earlier, so the Antoines equation. So model of, and our model takes 4 arguments, right? Our A, B, C, and t. So we have our A, B, C values stored in our result array right here, right? So the way we're going to import those is we're going to do asterisk res.x. And as you can see within result, they are under the x function in result. So what this asterisk right here does is it will pull all these results from the x values from our result and put them into our model. And then lastly, we need to take care of the t. So t will be tModel. Okay, and then name is equal to Antoines, and mode equal to lines. Now when we run our code, we should have a nice graph with our Antoines equation modeled very nicely. And we can zoom in and see our Antoines equation being predicted right here. So for a given temperature, so for 400 Kelvin, we can tell that our vapor pressure is going to be about 5.5 pascals. And that wraps up part 2 of this problem. Thank you guys so much for watching, and I hope you guys were able to learn a lot about the Antoines equation and how we can use Python to solve different chemical engineering applications. If you guys are interested in learning more about Python and chemical engineering in general, feel free to like, comment, and subscribe, and I'll see you guys in the next one.